Okay, let's try the last part of this function question. It says, if the equation of the horizontal asymptote of g, well, g is this green line, the hyperbola, if that horizontal asymptote is y equals 4, I'll put it right on in there, determine q and p. Well, they've just told you q if you know your stuff, so means q is equal to 4. What about p? Well, we know that this axis of symmetry here of the parabola is also the vertical asymptote. So whatever this -1 is here, you have to know that p is the opposite of it because you want it to whatever it makes it 0. So if we put in -1 there, we want p to be 1, so it makes it 0. It's the place the green line can never touch. It's undefined. So that's why p is 1 and q is 4. That easy. Now determine a. Well, now that we know q and p, we can put it in there, but we're going to have to substitute a point in. But what point do we have? Oh, we've got d. It's 0 and 6. So we put 0 in for x, 6 in for y, and we solve for a. That's how you do it. A divided by 1 is just a. Take away 4 from both sides. We get a is 2. Now determine the x-coordinate of f. Oh, didn't they tell us that? Oh yeah, fg, that is 6 units. That's a fancy way of telling you that because this is parallel to the y-axis, that's what they said here, if this is 6 right here, then the y-coordinate must be 6. Well, we can use that, and it sits on the parabola. So all we do is take the equation of the parabola and put a 6 there, and then solve for x. Take away the 6's, divide by -2, factor out the x times x plus 2. Oh, I can see, well, there's 0. This must be right at -2. I mean, a was -3, so it makes sense that x would be -2. So what are they just asked for the x-coordinate. They didn't ask for f, but I put it in there. The coordinates of f must be -2 and 6. And there you go.